Let us see what is given in the question. ABCD is our parallelogram. F is midpoint of DC, which means DF is equal to FC is equal to half of DC, and E is midpoint of AB, which means AE is equal to EB is equal to half of AB. This is what we got. But in a parallelogram, opposite sides are equal, which means AB is equal to DC, which means AE is equal to EB is equal to DF is equal to FC, which is equal to half of AB, which means AE is equal to EB is equal to FC is equal to FD. Let us consider the quadrilateral AECF. See, in the quadrilateral AECF, AE is equal to FC. We got this from here. And we also know that AB is parallel to CD, which means AE is parallel to FC. In a quadrilateral, if opposite sides are equal and parallel to each other, then the quadrilateral must be a parallelogram. Therefore, AEFCCF is a parallelogram. Now in a parallelogram, opposite sides are equal. Therefore, AF is parallel to EC. This is an important observation. Actually, from this what we can get is AP is parallel to EQ and PF is parallel to QC. We need these two conditions to show that line segment AF and EC trisects diagonal at BD. Now let us consider the triangle APB. Now triangle APB. See, in the triangle APB, we know that E is midpoint of AB. E is midpoint of a side AB, and we also know that EC is parallel to, EQ. EQ is parallel to AP. Right? We showed this from this condition. AP is parallel to EQ. Since E is the midpoint of AB and EQ is parallel to AP, Q must be midpoint. Q must be midpoint. This is from theorem 8.10. Therefore, Q is midpoint of side PB. Q is midpoint of side A PB, which means PQ is equal to QB is equal to half of PB. This is the first condition. Now let us look at the second triangle, that is DQC. Now taking the triangle DQC. See, in the triangle DQC, F is the midpoint of D and C. I mean, F is midpoint of side DC, which means DF is equal to FC, right? And we also know that PF is parallel to QC. PF is parallel to QC. Therefore, P must be midpoint of DQ. From 8.10, theorem 8.10, P is midpoint of a side. P is midpoint of DQ. Therefore, DP is equal to PQ. This is our second condition. See, DP is equal to PQ is equal to QB is equal to half PB. Therefore, line segments AF and EC trisect the diagonal BD. Hence proved.